All right, so let's start. I gave you an assignment. I hope you can hear me now. Hello. Okay, I gave an assignment. But let's look at one or two before we go look at the assignments I gave you. So in our discussion last time, we got to finding when you have a non-uniform displacement, a non-uniform velocity motion, or a non-uniform speed. And for a non-uniform velocity or speed, velocity or speed, a non-uniform velocity motion, we saw that the body covers unequal distances within equal time interval. And the example I gave a data situation, and that is if you have displacement time graph and you have values 0, time values 0, 1, 2, 3, 4, and so on and so forth. Then if it happens that the distance covered or the displacement of the body from 0, 5, 7, 10, 12, maybe to 15. When you have such a graph and then you plot the displacement against the time, S against the time, you have a graph or a curvy graph. Okay. You have a curvy graph like this. If the graph is curvy, now it means that you cannot, unlike a uniform velocity motion or speed motion, where we had a straight line, because equal distances covered within equal time interval. Okay, here when you find the slope of such a graph, the slope of displacement time graph or distance time graph is equal to either the speed or the velocity. Please, I hope you are following. Class, are you following?
Yes,
Please,
sir.
because of network situation, let me get feedback from you. So if it's a displacement time graph, the change in the slope is equal to change in displacement over change in time. If it's a distance time graph, then the slope is equal to the change in distance over change in time. So for a uniform speed or velocity motion, the slope is always equal to the velocity or the speed. Now, if the motion is not uniform, if the distance covered is non-uniform, you can only pick, okay, a time, maybe t is equal to something, t, and then draw a tangent. Please, when you come in, mute yourself, okay? Mute yourself. Mawuyo, please mute yourself. I'm getting a very bad feedback here. Hold on, let me mute all. All right. So, because this is non-uniform, you can only pick a time t is equal to something, draw a tangent to find the slope. Okay, to find the slope. And this will give you either the speed or velocity at or within a certain time. Within a certain time, which we call as instantaneous, either instantaneous speed or instantaneous velocity. So instantaneous speed or velocity. Please, I'm using speed and velocity at the same time because if it's a distance time graph, you will talk about instantaneous speed. If it is displacement time graph, we'll talk about instantaneous velocity. Please, is that okay? Class, is that okay?
Please, can you come again?
Yes, sir.
So if I'm using speed and velocity at the same time because the graph can either be a distance time graph or displacement time graph. If it's a distance time graph, then we can talk about instantaneous speed, meaning speed within a given time or instant. If it's a displacement time graph, then we can talk about instantaneous velocity, meaning the velocity within a given time t. All right. Now, for instantaneous speed or velocity, when we happen to have a situation where the distance or the displacement of the body increases with time. Example, the data I have here. Okay, the distance or the displacement begins from 0, 5, 7, 10, 12. So we realize that the distance covered is increasing with time. If it is increasing with time, then supposing I take a time t1 and I take time equal to t naught, and I take time equal to t2. Okay, because of the increasing distance, the instantaneous speed or velocity for time t naught, which will be this when I draw the tangent, and then the instantaneous time of speed or velocity for time t1, which can also be this bigger one, or the instantaneous velocity or speed for time t2, which when I draw would also be this bigger one. Okay, so I have three different triangles. This one, two, and then the largest three. Because the distance covered is an increasing one, when you find the slope for the three different triangles, you realize that the instantaneous speed or velocity would also be increasing. So if this triangle 1 maybe give us, let me clear this side of the board. So if the smaller triangle 1 give us a slope of maybe 1.0 meter per second, which is equal to the velocity or the speed. The the larger triangle 2 can also give us a slope which can be, I'm assuming figures, maybe 2.5 meter per second, which is also the slope, or which is the velocity or the speed for this larger triangle. Then the third largest triangle, 3, which is for the time t3, can also give us a slope equal to maybe 4.0 meter per second. And this would happen because the distance or the displacement of the body increases with time. And so we'll have their slopes also increasing, or their speed or velocity also increasing. Now, if we have 3 different slopes, which is equal to velocity or speed, and it is increasing. If with time, the velocity is increasing or the speed is increasing, what will this amount to, or what will this give us? Yes, if you have a situation where due to the increasing distance, the speed or the velocity is also increasing with time, what can you deduce from a situation like this? Yes, anybody to share his or her observation with us? Hello, Della. Hello, Della.
Yes,
Can you share your observation? Yes, if you have a situation, 3 situations, T0, T1, T2, and then the slope increases. The slope is equal to the velocity or the speed, and it is increasing with time. What can this, or what information can we deduce from this? What information can you deduce from a situation where the velocity increases? Come again. Della, come again.
Also, with time, speed increases.
Okay.
I don't get the question.
We have considered 3 different slopes at T0, T1, T2. And we realize that the slope, which is equal to the velocity or the speed, increases with different times, T0, T1, T2, at different instances. So if you have a situation where at different instances or time, the velocity or the speed increases, then what can you generally say about that situation? That's the question. Let me have the guys also coming in. Kweku and Co, come in. Yes. Do you have any idea? All right, let me, because of time and network. So if you have a non-uniform velocity motion, okay, and then the distance increases with time, then the body can be accelerating. For a non-uniform velocity motion, bodies also accelerate. Bodies accelerate because at different times, at different instances, the slope, which is equal to the velocity, increases. Also can increase or can decrease due to the distances increasing or decreasing. So for a non-uniform velocity motion, bodies accelerate. Okay, so we have 2 main deductions from a non-uniform velocity motion. 1, For non-uniform velocity motion, one, we have what we call instantaneous speed dash velocity. So we can obtain the speed or velocity within a given time or instant. And two, bodies also accelerate. So under a non-uniform velocity motion, there is also acceleration of the body. And this is because if we have a situation where the distance covered increases or decreases with time, then bodies can either accelerate or decelerate. Class, are you okay? Are we okay?
Yes, please.
All right.
Yes, please.
Then the last graph to look at under displacement or distance time graph, then we move on to velocity time graph. I want you to look at this graph carefully and tell me what it is. It's a distance time graph. Now this is what we have. I want one of you to tell us what this graph actually means. What does it mean? What does the graph mean to us? Kweku, go ahead. Hey, Kweku, your hand is up. Go ahead and try.
It means that the body has already covered the distance and it remains, it's not moving.
Kweku, what? Okay, can you tell me why you think so? Why do you think the body is at rest or is stationary?
Because a horizontal line has no slope.
Good. Thank you. That's very good of you. Look, we saw that when there is a slope, when you have this, for a distance or displacement time graph, please, the slope is an angle. When I take change in the vertical, which is displacement or distance, against change in the time, the slope refers to this angle, theta. So the slope, which is actually equal to delta S on M over delta T, actually refers to, if you have done trigonometry, when you have a right angle triangle, what name do we give to the ratio of the opposite side to the adjacent? If you have done trigonometry, if you have a right angle triangle, what name will you give to the ratio of the opposite side to the adjacent? Yes. Paulette, go ahead.
Please, tangent.
Exactly. So this
Tangent.
is, thank you. This is tan theta. So the slope refers to the tangent of the angle. Okay. Okay. So it just simply, you can also say that For a displacement time graph, the slope is equal to the velocity or the speed. And so we can also say that tan of the angle theta is equal to the velocity, because for a displacement time graph, the slope is equal to velocity. So I can equate this to the velocity. Please, are you okay? And watch this carefully. So if you have a slope and this angle is the same from start, so the slope is constant, the angle is constant. Because the angle is constant, we can say that, okay, then this is equal to a constant or uniform velocity. Please look at the build-up. Because this angle is constant, is the same throughout. If it's 30, it doesn't change. This will still be 30 when you use protractor. So because this angle is constant, then I can say that this is equal to a constant or uniform. This angle refers to the speed or velocity or speed. That is why we give this the name uniform velocity motion. Uniform velocity motion. It is because the angle is uniform or constant, and the angle is equal to velocity or speed. Hence the name uniform velocity motion. Now, let's come to this one. Over here, the slope or the angle is equal to 0. If the slope is equal to 0, then we can say that the velocity or the speed is also equal to what? Yes, class. The velocity or the speed is also equal to what?
0.
0. Good. Now, you have a body and its velocity is 0. What can you say about the body? What can you say about the body, Paulette? If you have a body and its velocity is 0, what can you say about the body?
The body is at rest.
Yes, the body is at rest or is stationary. Hence, this is whenever you have a displacement or distance time graph and the slope is 0, then body is at rest. Body is at rest or stationary. Body is at rest because the slope would give you the speed or velocity, but the slope is 0. If the slope is 0, then the body is stationary. Another way to understand this, a body starts motion at t is equal to 0. The body's position is here, maybe 5 meters. So Kweku starts a journey at t is equal to 0. This is Kweku's position. Time continues to increase on and on and on. But as time increases, maybe 2, 4, 6, 8, 10. As time continues to increase, when we try to locate Kweku's distance or displacement is at the same position. Okay, so let me connect it to a practical situation. Maybe there is a 100-meter competition between myself and Kweku. Knowing myself to be a very good sprinter, I decide that no, Kweku, instead of starting with you, I'm giving you 50 meters. Start your journey from 50 meters whilst I start from 0. Meaning I've given you, dashed you half of the journey. Now, as the whistle went, I start the journey, and Kweku's position as the time continues to go is at the same point given to Kweku. Can't I draw the conclusion that Kweku is stationary? Okay, so this is what it means. So for a displacement time graph, when the slope is 0, it means the body is stationary or at rest. Now the last one, which I talked about for instantaneous velocity. So when the distance covered increases with time or decreases with time, when you plot for the increasing one, when the distance covered increases with time, but in a non-uniform manner, when you plot such a graph, this is what you have. Now look at the slope, or which is the angle. At time t is equal to this, the angle, the curve makes with the time axis. This is 0. As time increases, what is happening to the angle between the curve and then the time axis as time increases? Yes, what is happening? Plus, what is happening to the angle between the curve and the time axis as time increases? Well, the angle is increasing. Now, if the angle is increasing, then it means that the slope is increasing. If the slope is increasing, then what is increasing? If the slope, the what?
Velocity.
The velocity is increasing. When you have an increasing velocity, then with time, then certainly bodies would accelerate. The reason for which for a non-uniform velocity motion, bodies accelerate. If the distance covered is also decreasing, okay, then it means the slope would decrease, and so body would decelerate. That is the whole thing. But don't forget, acceleration can be positive, negative, or can be 0. If it is a negative, we give it that special name, deceleration or retardation. But the word acceleration applies to both negative and positive. Any question? Any question? No question. Let's look at this velocity time graph or speed time graph. We've discussed everything under displacement or distance time graph. Okay, and last thing then. So if the graph is this is uniform or constant speed, because the slope, which is the angle between the line and then the time axis, is uniform. If we happen to have this, so here the slope, which is equal to the velocity or speed, is positive. If we have this situation, And this one, and it's a distance or displacement time graph. What it simply means is that the displacement or the distance covered decreases with time. So at t is equal to 0, the distance or displacement is this, maximum. As time continues to increase, you realize that the distance decreases as shown by the arrows. Okay. So this one, when you find the slope, yes, this slope is also constant. Constant. So this will also give you a constant or uniform velocity. But when you find the slope, it's a negative, telling you that the body is moving towards the opposite direction. Okay. Or the body is moving back to the starting point. That's the origin. Over here, it is moving away from the origin. So as time increases, the distance covered is also increasing. So body is moving away from the origin, starting point. Over here, the body is moving in the opposite direction or moving towards the origin. And so the slope will be equal to a negative. Negative because slope is changing displacement or distance over the change in time. Now, when you calculate for the change in displacement is also always equal to the final displacement minus the initial displacement over t final minus t initial. Okay, so when we calculate what's the final displacement, the final displacement can be anything less than the maximum 1 or 0. If maybe the body has come back to the fixed point, then x final can be 0 minus initial, the maximum value, xi, over the time is always positive because time is a scalar quantity. So the final time, which is a larger value, minus the initial time, which is 0. And so when you find such a slope, you get 0. Okay. Sorry, you get negative, telling you that the speed is negative. Negative speed simply means that the body is moving towards the opposite or moving in the opposite direction. Class, are you okay? Are we okay? If you want to ask a question, go ahead.
Sir, please can you go over?
Paulette. What I'm saying is that we can also have a situation where a body is moving towards, okay, opposite to at the starting point. And our starting point, we are looking at the origin, O, at a fixed point. Okay. Now, if the body is moving away from the origin or the first point, then as time increases, the displacement of the body can be increasing. And this is what I'm talking about. Displacement time graph. That is the origin O. So if you plot a graph and it's like this, the slope is uniform. It means the velocity is uniform or constant, hence uniform velocity motion. Here, what it means is that at time t is equal to 0, the position of the body is 0, or the distance covered is 0. Now, as time increases, T1, T2, T3, T4, and since we are moving towards the right of it, means we are looking at increasing time. You realize that as time increases, the displacement of the body also increases. Practically, what it means is that the body is moving away from the mean point. So the body's position with reference to the fixed point or the starting point is increasing. Paulette, are you okay? Paulette, are you okay?
Thank
Good.
you.
Now, we can also have a situation where as time increases, the body returns. Okay, so this is like this. Over here, this is like this. We can also have a situation where as time increases, the body's position or the body is moving towards the starting point O. And when you plot such a graph, you have a negative slope. You have a negative slope. So this is how such a graph would look like. Over here, this is it. This is the direction. Meaning at time t is equal to 0, the body's position is maximum. Okay, maximum. Now, as time increases, we realize that the body's position decreases or moves towards the starting point. Now, when you find such a slope, the slope is a negative because of the direction of the position or the displacement of the body. So you have the slope for a displacement time graph is the speed or velocity. And when the velocity is negative, all that it means is that the body is moving towards the starting position or point. So the negative only implies that the displacement of the body is towards the starting point or the origin. That's all that I'm saying. Class, are we fine?
Yes.
All right. Let's look at velocity time graph. Then we look at the question. Velocity time graph. So all that we've done is for displacement or speed time graph. Those of you who joined us late because of the bad network situation, please we started with the displacement time graph. So pay attention to this one so that you pick it from there, right? So velocity or speed time graph. It can be both. Velocity time graph. So here, what we are doing is that we are plotting either the speed or the velocity of the body against time. Time is an independent variable, okay? And so that is always plotted along the horizontal. Then the dependent variable, which is the speed or the velocity of the body, is always along the vertical. So velocity slash its units. and time slash its units. Now, if we happen to have a moving body whose velocity increases at equal intervals with equal time, just as we saw. So here we are talking about velocity t. Now the data we have is such that at time t is equal to 0, there is no motion. So v is 0. 1, 2, within time increases within equal intervals. 2, 4, 6, 8. So time increasing within equal intervals, the body covers equal distances within a specified direction, displacement. So within equal time interval, the displacement of the body is also in equal intervals. Okay. So when a body moves such that its speed changes within equal time interval, when you plot such a graph, 1, 2, 3, 4. 1, 2, 3, 4. So 2, 4, 6, 8. So at time t is equal to 0, velocity is 0. At time t is equal to 1, the velocity or speed of the body is here. 2. Time t is equal to 2. The velocity of the body is this. Time t is equal to 3. 6. T is equal to 4. When you join these points, these plotted points, you can have a straight line. Where we have a straight line. This straight line, what deduction can we make out of it? This is velocity time graph. The slope of a velocity time graph, delta V meter per second, delta T. So slope, which is equal to change in V over change in T. Okay. If you have change in velocity with respect to change in time, this will be equal to the rate of change of velocity with respect to time.
Acceleration.
This is acceleration. So one key deduction is that for a velocity time graph, the slope is equal to the acceleration of the body. So the slope of a velocity time graph is equal to the acceleration of the body. Now, this acceleration is uniform because when you pick any two values, any 2 points on a straight line, and you find the slope, you get the same value. So if you pick this point, A and B, and find the slope, let's pick two, between A and B, and then we find the slope. Slope is equal to change in vertical. What is the change in the vertical? That's a 6 minus 2. 6 minus 2 over change in the horizontal. This is 3 minus 1. So 4 over 2. And this is equal to 2 meter per. This is equal to 2 meter per second squared. I can also choose different points. Maybe this time I want to pick the extreme points. The one at the origin and then this one. And so I want to use this triangle to find the slope. The slope of the second situation would be the maximum 8 minus the minimum is 0 over the time interval. Maximum 4, minimum 0. And so this is also 2 meters per second squared. So you realize that for a uniform velocity motion, the slope or for a kind of motion whose velocity increases within equal intervals, has a uniform slope all along. And because the slope of a velocity time graph is equal to acceleration, we term this motion as uniform accelerated motion. Uniform accelerated motion. So for a uniform accelerated motion, the body moves with equal speed or velocity within equal time interval. Or for a uniform accelerated motion, the rate of change of velocity with time is uniform or constant. Class, do you have any question to ask? The other thing to add is the angle. Velocity time graph. And if it's uniform, look at this angle. This angle is the same throughout, or is the same on the line, on the straight line. So theta is constant. So over here, when we pick the extreme point and draw a right angle triangle, we can also say that the slope is equal to delta V on delta T. And this slope is equal to the tangent of the angle of tilt. So tan theta is also equal to delta V on delta T, which is also equal to acceleration. So take note of this. I'll be giving you different questions to see how this applies. Okay. So because theta is uniform or constant, and theta is the angle, is the slope, then we can say that this is a uniform uniform accelerated motion, just as we spoke about earlier. Now, if the velocity decreases with time, okay, then we'll have uniform decelerated motion. Then when you plot the graph, it will be the other way. The slope will be a negative, and the slope is equal to acceleration. So if we have a decreasing velocity with time, then it will be uniform decelerated motion. Class, are we okay?
Yes, sir.
All right. Michael, this question is for you. Michael, we have velocity time graph. I want to see how a female micrododo can apply. Velocity time graph. Michael, this motion is like this. What does it mean? Michael Dodu. Under a velocity time graph, we have such a motion. Michael, what does it mean? Michael, are you there? Okay. Maybe Michael is still engaging his or her brain. Okay, Ayo, Samson. Ayo, are you here? What meaning
Yeah, I'm here.
what meaning can you draw from this? For a velocity time graph, if it's like this, what does it mean?
The body has constant acceleration. No acceleration, sorry.
Jojo, you are giving me two answers at a time. Which is which?
No acceleration.
Why?
The acceleration is 0. Because the body has been at the same velocity for a long amount of time.
So, zero acceleration, which means that, which also literally means that
The body started at the body has kept this initial velocity for this long amount of time.
Okay, thank you, Jojo. Well, are you there? Okay, Yasmin, your hand is up. Let's hear from you too. Share what you see with us.
Please, sir. Please, it means that the body is at rest.
Okay, Yasmin is also saying that it means the body is at rest. And finally, let me pick this view from Kweku. Kweku, what do you have to say? Kweku?
I say the body is at rest.
Okay.
There is no acceleration.
Okay. You see, thank you. Thanks for the 3 excellent contributions. So let me polish it. Yasmin and Kweku, when you are given a graph, I think Jojo had it on spot. His answer, okay, earns the 4 marks. When you are given a graph to interpret, you first must look out for what kind of graph is this? Is it displacement time graph? of course, displacement time graph and the distance time graph are similar. They differ in a little, which I'll talk about. Or you must also ask, is it velocity time graph? Is it accelerated or acceleration time graph? This is a velocity time graph. Now, for a velocity time graph, that's time graph. Yasmin, the slope is equal to what? Yasmin, what is the slope of a velocity time graph?
Change in velocity over change.
So change in velocity over change in time is equal to what? It's equal to what? Yeah, somebody to answer that for Yasmin. The slope change in velocity over change in time is equal to what? Please go ahead and answer.
Acceleration.
Yes. So
Please,
the slope,
acceleration.
thank you. So the slope of a velocity time graph is equal to the acceleration. Slope is how, okay, slope talks about how the line, the motion represents the line, how the motion connects to the time axis. Okay, so if the graph, which is the motion, connects to the time axis in such a way that the angle between the time axis and then the motion is zero, then it means the acceleration is zero. If the motion, which is the graph or the line, whether a straight line or curve, connects to the time axis in such a way that the angle between the time axis and then the graph, which is the motion, is zero, then it means the acceleration is zero. And when the body has a zero acceleration, what does it mean? It simply means that there is no acceleration, is change in velocity over time. The velocity is not changing. The initial velocity is equal to the final velocity. So the velocity is not changing. And Yasmin.
Yes, please.
If a moving or a body is such that its velocity, if its initial velocity is equal to the final velocity, Yasmin, does it mean the body is stationary?
No, please.
No, it's in motion, but the body's velocity or speed is not changing. Okay, so this is a graph of zero acceleration, or the body is moving with a constant velocity. So you must look at the kind of graph, whether it is velocity time graph or displacement time graph. I'm giving you another one. The contest is between this and this. Paulette, are you there? Paulette, are you there? Oh, the network has sent her home. Yasmin,
Yes,
back to you. Yasmin, I have these two graphs. Watch it carefully. This is a displacement time graph. This is a velocity time graph. House. Yasmin would answer first, but the question goes to the whole house. What is the difference between these two graphs? What is the difference between the two graphs on the board? Yasmin, are you ready? Uh-huh. Mhm.
The velocity time graph, there's but then this
Yasmin, my question is that are they different? Are they the same?
these are different.
Okay. Bring out the difference between them. Yeah, Yasmin, give me the difference between the two. Okay, let me pick Jojo. Oh, let me call somebody. Henry, Adam, you are here. Juliana, Osei, Joel, Nana Kwame. Hey, people are hiding here. What is the difference between Nana Kwame? Let me pick your view. Are they the same? Are they different?
Yes, sir.
Which one is which is which? Are they the same? Are they different?
They are different.
Uh-huh. Okay. Cadmiel, I'll come to you. Uh-huh. What is the difference? Bring out the difference between the two. Okay, Juliano say is ready. So now I hold on. Let me take Juliana, go ahead.
Please, in the first graph, the velocity keeps changing with time, and then with the second graph, the body is in motion, but then it's constant.
What is constant, Juliana? Juliana, what is constant? Okay, nice view. Okay, I'll polish it for you. Okay, let me now open the floor to anybody. If you think what you've seen is the absolute view, share with us. What have you seen? Are you? Okay, Michael, go ahead. Michael Dodu.
Yeah. So with the displacement time graph, the body is in motion. It's accelerating. Its acceleration is changing. But with the velocity
Michael,
time graph,
Michael, tread carefully, oh. Tread carefully.
the velocity time graph, it's in motion, but it's not. Its acceleration is not changing.
Hey, Michael. All right. Jojo, Jojo, go ahead. Let's have Jojo's view as a final contribution. Jojo, go ahead.
Please, sir. I think that they are the same.
Why?
This is because in the displacement time graph, there is a constant velocity or a uniform velocity. The same thing to that in the velocity time graph too, there is a constant or uniform velocity.
In fact, let's clap for Jojo. Let's clap for Jojo. That is it. Wherever you are, clap for Jojo. Yes, these two graphs are the same. The two graphs are the same. Here, yes, the body is in motion. This is a displacement time graph, meaning that the body moves, covers equal distances or this displacement within equal time in intervals. Okay, and the speed is uniform. The velocity, don't forget, for a displacement time graph, the slope is equal to the velocity or speed. Well, it's a displacement, so I'll talk for velocity. Okay, now this velocity, uniform velocity, can be a certain value, maybe 10 meters per second. This is also a graph whose acceleration, acceleration is not changing. The acceleration is actually 0 because its speed is not changing. But if the acceleration is 0, then it means the body's velocity is constant, the same value. It can be the same value, 10 meters per second. So this is actually the twin brother of or sister of this one. They are the same graphs. Class, are you okay?
Yes,
Yes, sir.
All right. Then so we've talked about velocity time graph when acceleration is 0. Now, if the bodies, then we've also talked about the same velocity time graph when the t graph, when the acceleration is uniform accelerated motion. Over here, A is constant or uniform. And over here, VT, A is 0. Then non-uniform accelerated motion, VT. For none, this is non-uniform accelerated motion. Henry, Adam, mute yourself. Adam, next time I'll condemn you. Can somebody explain this to me? Non-uniform accelerated motion connected to one of the motions with length. And then explain this to me. Non-uniform accelerated motion. Can somebody help me? A volunteer to help me. Oh. Who would volunteer? Hey, okay. Della, go ahead.
The graph shows that the body might be in a random motion.
Della, random motion, I won't buy it. Kweku, yes, the observation is okay, but random motion, no. Kweku,
It means the graph has a changing slope.
it's true. What again? Kweku, what again? A changing slope, and the slope is increasing. So over here, it means we cannot find, it's a velocity time graph. Each slope is equal to what? For a velocity time graph, each slope is equal to
Acceleration.
acceleration. So it means over here, we can only find for instantaneous acceleration. Acceleration within a given time. So maybe I want to determine the acceleration at a time t is equal to so and so. So let me draw it well. Similar to what we saw on displacement time graph. So maybe I want the acceleration at a time t is equal to something. So I draw a tangent through the time. Maybe this is T naught, this is T1. So change in the vertical, change in the horizontal. We connect this point, T is equal to T1. We determine it corresponding V. So the slope would be equal to delta V on delta T. So we have V minus 0 over T1 minus T naught. So this will give us the acceleration at a time t is equal to 1, instantaneous acceleration. Class, are we okay? Give me feedback. Are you okay?
Yes, please.
All right. Last observation. And the observation is this. So we've gone through when it is, so this is when the velocity is increasing. We can also draw it for when the velocity is decreasing. Okay. In that non-uniform manner, I mean. In that non-uniform manner. If it's a decreasing velocity, this is how it will look like. So over here, at time t is equal to 0, this is the velocity. As time increases, the velocity would also be decreasing. So this would also give us a non-uniform decelerated motion. A non-uniform decelerated motion, whereas this will give us a non-uniform accelerated motion. So a non-uniform accelerated motion goes with an increasing time, but okay, at non-equal intervals. This also, sorry, an increasing velocity, okay, with not in equal intervals. This is a decreasing velocity, not in equal intervals as well. I want one of the ladies. It can be Della, Paulette, and the rest of you. Juliana say, and all the ladies in the building, answer this for me. I have two graphs. This is displacement time graph. And the graph is like this. I have another graph. This is velocity time graph. The graph is also like this. Are they the same? Or what is the difference between these two graphs? Ladies, this is for you. Juliana, Della, are you still around? Juliana. Hey, are you girls there? Della, are you there?
Yes, please.
Hey, answer time. Are they the same? Are they different?
Yes, I think they are the same because their slopes they are all equal to 0.
Hey, Della, what well? Oh. Della, open your eyes. Oh. Juliana, are you around?
Yes, please.
What do you also say? What do you also have to say about the question? Okay. Nana Kwame, give me your opinion. Nana Kwame, are you there?
Sir, please. Yes, sir.
Mm-hmm.
Please, I'll say they are different.
How different are they?
Sir, please, the first one is displacement time graph.
Yes, we can see.
And the second one is a velocity time graph.
Nana Kwame, I won't score you for, I won't give you anything for this observation. I won't score you. Is that all, Nana Kwame?
Uh,
Because the lie is back. The lie wants to still
um,
contribute. Is that all? Okay,
sir, please, I'm
Dela.
thinking.
Okay, Dela, give us what you have seen.
And
Oh, mm-hmm,
the velocity graphing, the second one,
mm-hmm.
is the acceleration is constant, the speed is constant.
Hey, Dela.
And
Dela,
the first one is 6, 9. Yes.
Dela, you are missing two different stuffs. Okay, time, because of time, let's hear from Jojo and then we continue. Jojo, what do you have to say?
And please say they are different.
How different are they?
The first one, the body is not moving. It has been at the same distance for a certain amount of time, so it is not moving. The second one too, the acceleration is constant.
Body
It's at,
is
it's
at
at rest.
rest. Uh-huh. And the second one,
The second one too, there's a constant velocity, no acceleration.
constant velocity is 0. So, Jojo, so what will you say about this? Okay, let me add the other ingredients. Jojo, this observation that body is at rest is correct, but you should have spiced this up with velocity is 0. Do you get it? Della and
Yes, sir.
Juliana, and then Nana Kwame, and the rest of you, please. Okay, here slope is 0. Once the slope is 0, it means velocity is 0. So body is at rest. Slope is 0, meaning acceleration is 0. So body moves with constant velocity. Body moves with constant or uniform velocity. Please, class, are we okay?
No.
Are we, Juliana, are you okay?
Yes.
A very last one. Then we go back to, we look at the question I gave you. And I'll just modify this. I'll simply modify these two graphs. And still, it's for the ladies. The question is still for the ladies. Juliana, I wish I have the names of all the ladies in the building. So tell me what you have seen about these two graphs. What have you seen? Are they the same? Are they different? Juliana, and the rest of you. Please, let's be snappy with our responses because of time. Okay. Who is starting for us, Della or Juliana? Hey. Okay, a different view. A different view. Please, if you've seen anything or if you have something to say in connection with the two graphs, quickly share with us and let's move on. Jojo.
Yes, sir.
Go ahead. Let's not waste time. Quickly give me your opinion.
Please, in the first one,
Mhm.
there is acceleration. There's
Which
a
one?
constant acceleration.
Which one?
In the second one, sorry, in the velocity time graph, the second one. In the second one, there's a constant acceleration, meaning the velocity is gradually increasing. But in the first one, the velocity remains constant.
Come here again. Is that in the second one?
In the velocity is gradually increasing.
It's
And in the velocity keeps increasing because there is acceleration.
So here is acceleration constant.
Yes, sir.
A is constant or uniform. So if acceleration is uniform, what it means is that the body is moving with equal speed within equal time intervals. Please note that body moves with equal velocity or speed within equal time interval. So it's like, okay, from 0 to 4, 6, on and on and on. So that when you plot the velocity time graph, you get this. Now over here, in one, is the body in motion?
Yes, sir.
Okay, so V is also constant or uniform. And what it means is that body covers equal distances or displacements within equal time interval. So that's the difference between them. They are very, very similar, but in judging the kind of motion, please look at whether it's a displacement time graph or velocity time graph. Now for acceleration time graph, and I'll do that quickly because let me check the time before. We need to 34. Okay, so I'll use about 5 minutes to talk about this. Then we'll solve today's question. In acceleration time graph, there are two possible graphs. This is usually beyond your level, but it isn't difficult. So let me take you through about two of them. Acceleration time graph. We can either have this. Okay, there are three. If you are given acceleration time graph and you have this implies that no acceleration. Acceleration is 0. Or A is equal to 0. I think let me clean what we have here, right? So if you have this, it means A, no acceleration, or A is 0. Then if you have this, this also indicates constant or uniform acceleration. And finally, if you have A against T, and you have this also indicates varying or variable acceleration. So it means that there's also a connection between, if you have acceleration time graph and you have this, and then a velocity time graph, and we have this. These two graphs are the same, constant or uniform acceleration, and this is also constant or uniform acceleration. Class, are you okay?
Yes, please.
Yes, please.
All right. Then back to the question I gave you. Jill walks at a constant speed to her friend's house 120 meters away in 60 seconds. Jill walks at constant speed to her friend's house 120 meters away in 60 seconds. After talking to her friend for 30 seconds, she returns home at constant speed in 40 seconds. Draw a displacement time graph and a velocity time graph for the motion. This question, a lot of you tried. In all those feedbacks I had, I think a lot of you also had the displacement time graph correct, but the distance time graph actually flawed a lot of you. The thing is that when we talk about displacement has to do with the position of a body with respect to a certain fixed point or origin. Displacement has to do with the position of a body with respect to a certain fixed point or the origin. So over here, we are looking at the position of the body and then referencing it to